Welcome back. This is part 8 of a 9-part series on completing the square. In this video, we'll apply the completing the square method to a projectile motion problem, which is a common problem in introductory physics. Get some paper and a pencil, and let's get started. Here's the problem we want to solve. A projectile is launched from an initial height of 2 meters above the ground with an initial velocity of 15 meters per second at an angle of 20 degrees above the horizontal. Find the time it takes for the projectile to hit the ground. Ignore air resistance. First, let's talk about projectile motion more generally. When an object is thrown near the surface of the Earth, and in the absence of air resistance, it takes a parabolic path. That motion can be broken down into a vertical motion and a horizontal motion. In the vertical direction, also called the y direction, the motion is the same as a ball thrown straight upward. In the horizontal direction, also called the x direction, the motion is the same as an object moving with constant velocity. Let's break this problem down. The projectile is launched from an initial height of 2 meters above the ground. The initial height is yi equals 2 meters. It has initial velocity of 15 meters per second, so vi is 15 meters per second, and the angle is 20 degrees above the horizontal. It asks us to find the time it takes to hit the ground. This time is delta t, the change in time. But if we make the initial time at launch ti equal to 0, then we can replace delta t with the final time, t. It hits the ground, which means that the final height is y equals 0. We also notice that the time in the air only depends on motion in the y direction. The equation governing the vertical position of the projectile as a function of time is given by the equation y equals yi plus viy times t minus 1/2 g times t squared. Let's see if we have enough information to use this equation. The final height, y equals 0. The initial height, yi, equals 2 meters. viy is the initial velocity in the y direction, which we do not yet know. To find this, we need to examine the initial velocity vector. We decompose the vector into its x and y components. The y component is viy, the initial velocity in the y direction. This is a right triangle, so we can use trigonometry to find the side of the triangle. We get viy equals 15 meters per second times sine of 20 degrees, which is equal to 5.13 meters per second. Then, t is unknown and is what we want to solve. Finally, g is the magnitude of the acceleration due to gravity, which is 9.8 meters per second squared. Let's plug these values into our equation. If we reorder this equation, first by moving the 0 to the other side, and then moving the highest power of our variable t to the left and the constant term on the right, we can see the similarity to the quadratic function ax squared plus bx plus c equals 0. Instead of a function of x, it is a function of t. This means that we can use the completing the square method to solve for t. I'll warn you in advance that completing the square is not the easiest method to use to solve this problem. A little later, I'll go over some alternative methods, but to complete the square, we need to get it into the common completing the square form. First, we move the constant term to the other side. Then, we see we have a leading coefficient, negative 4.9 meters per second squared. So we divide every term by this leading coefficient. The negative 4.9 meters per second squared cancels in the first term. We get t squared plus 5.13 meters per second over negative 4.9 meters per second squared times t equals negative 2 meters over negative 4.9 meters per second squared. Let's combine the units. This is the same as dividing fractions, so we're going to multiply by the reciprocal. First, we bring up the units from the denominator, but when we do that, we have to flip them. The meters cancel, and in the second term on the left-hand side, one of the seconds cancels as well. Calculating the values, we get t squared minus 1.047 seconds times t equals 0.408 seconds squared. To complete the square, we find b and b over 2, and then we add b over 2 squared to both sides. That allows us to write the left-hand side as a perfect square. The terms on the right-hand side can be combined. We then take the square root of both sides and include a plus or minus on the right-hand side. The square and the square root cancel on the left-hand side. We evaluate the square root on the right-hand side. We move the constant term to the right-hand side, and when it arrives there, it becomes negative. We solve for t and get plus or minus 0.8269 seconds minus 0.5235 seconds. We write out the solutions and evaluate them. The first solution is t equals 1.35 seconds. If we go back to the original problem, the ball is launched at t equals 0, and it hits the ground at 1.35 seconds. The other solution is t equals negative 0.30 seconds. We get a negative time. What is a negative time? It turns out that this is the solution when the quadratic function is evaluated along the negative axis. This equation describes the entire quadratic function, not just for positive values. You have to use your conceptual understanding of the physical situation to properly interpret the results. To be honest with you, completing the square is not how most students prefer to solve this kind of problem. In my experience, most students prefer to use the quadratic equation x equals negative b plus or minus the square root of b squared minus 4ac, all over 2a. If we compare our equation with the quadratic function, we see that x is replaced with t, a with negative 4.9 meters per second squared, b with 5.13 meters per second, and c with 2 meters. We plug these values into the quadratic equation, evaluate the terms, and the solutions are t equals negative 0.30 seconds and t equals 1.35 seconds, which are the same results we got by completing the square. The other alternative to completing the square is to avoid the quadratic function altogether, using these two equations involving the final velocity in the y direction, vfy. If we plug the values we know into the equation at the top, we get this equation. And when we solve for the final velocity in the y direction, we get vfy equals plus or minus 8.09 meters per second. We plug those values into the lower equation, and in this equation the only unknown is the time t. When we solve for t, we get the two solutions t equals negative 0.30 seconds and t equals 1.35 seconds, the same answers we got using the other methods. That concludes this lecture. If you liked it, then click the like and subscribe buttons below. In the next video, we'll discuss how you might use completing the square to evaluate integrals. See you next time.